Welcome back to the Successful Farming Podcast. In today's episode, Lorrie Boyer talks with Dan Smith, Program Manager at the University of Wisconsin-Madison's Nutrient Pest Management Program, about how Wisconsin farmers are using cover crops, manure credits, and nutrient planning tools to cut costs, improve soil health, and boost sustainability. Today's podcast is brought to you by BASF, committed to providing innovations that help farmers do the biggest job on earth.
Farming never stops, and neither does Mother Nature. Every year, farmers face new weather, pest, and disease pressures. That's why BASF invests over $3 million per day in research and development. From the lab to the field, our team works to create smarter solutions, new chemistry, new active ingredients, and new seed products that perform. It's how we help farmers do the biggest job on earth.
Welcome to the show. I'm Lorrie Boyer, and my guest is Dan Smith, and he is the program manager for the Nutrient Pest Management Program at the University of Wisconsin-Madison Division of Extension. As we get started on the show here today, Dan, tell us more about yourself and your background and how you came to be in this role with the University of Wisconsin-Madison.
Yeah, absolutely. So I began my journey at University of Wisconsin-Madison as the Southwest Regional Agronomist in 2016. And in that position, I helped farmers manage nutrients on the landscape and address challenging weed control issues, primarily with cover crops. So I've worked a lot in implementing nutrient management planning on the landscape, helping farmers allocate manure credits, use legume credits from crops such as alfalfa. As we're in Wisconsin, we have a lot of dairy farms. And then an interest that began in grad school working with cover crops, using winter rye to suppress troublesome weeds like water hemp. So building in more of a systems approach to weed management. And along the way, I picked up the interseeding work where we helped design trials to interseed cover crops into corn, looking at primarily red clover, some brassica species, some grass species to help farmers, again, hold soil on the landscape, help better cycle nutrients, and suppress weeds possibly. Now, today, I run the Nutrient Pest Management Program for the University of Wisconsin. So I help regional agronomists across the state, again, help farmers manage nutrients primarily within that role. But everyone has a specialty and a little bit of a niche, and we're part of a bigger team, the Crops and Soils Program at UW-Madison. We help farmers on a wide range of topics, primarily in those dairy livestock systems. But again, we have a lot of grain production in Wisconsin too. So we get tons of questions on pest and nutrient management challenges.
Dan, let's dive in a little bit deeper. Tell me what exactly the Nutrient and Pest Management Program entails.
Yeah, absolutely. So throughout the winter, we'll have farmers come to classes that are set up by land conservation offices in each county, and they'll come in to write a nutrient management plan. So during that process, they'll learn about nitrogen, phosphorus, potassium, soil pH management, along with soil conservation practices as well, including the use of cover crops. And then they'll develop a nutrient management plan for their actual farm. So they'll bring in farm data such as number of livestock, acres they're farming, maybe some challenges that they want to address throughout this planning process. And the team will help them then allocate their manure on the landscape, help them decide how much nutrients to purchase. And then finally, they'll put all that together within the SNAP Plus program, which is a University of Wisconsin product that helps farmers plan nutrients on the landscape. That program maps the fields. The farmers allocate nutrients on those fields. It tells what the nutrient balance is on those fields and if there's any soil or phosphorus loss issues that need to be addressed. So it's a pretty holistic process. Typical class is 2 days, and farmers go through that every 4 years at a minimum. If they're writing their own nutrient management plans, they can, of course, work with their agronomist to have this done for them too. And those plans are updated annually.
And what are some of those common challenges that you refer to that producers face?
Yeah, absolutely. So the most common one that I've worked with in the driftless region of the state is soil conservation. So too much soil loss. They know that they're having erosion challenges. Their current cropping practices may include some tillage in the fall. We get some spring rains and that soil runs off that hillside. We get some ephemeral erosion, which is visible from the road. And no one wants to lose soil. It's impossible to replace, of course. So working with farmers to incorporate some reduced tillage practices, maybe some no-till planting, especially with soybeans in the crop rotation. This can be a challenge on higher slopes. That's the biggest challenge. The second biggest challenge is manure allocation. Historically, the manure's been spread close to the barn because in the wintertime, it's tough to go any further than that. So allocating manure where there's lower soil test phosphorus levels out onto the landscape, onto fields that they may be purchasing commercial fertilizer is a way that we see farmers save $20,000, $30,000, $40,000 annually by doing nutrient management planning on even a average size small Wisconsin farm. It's very surprising how quickly those credits can add up and how quickly we can look at saving some substantial dollars.
Dan, as you're talking about credits, what exactly does that mean?
Yeah, so the easiest example is this alfalfa field that's actually beside me will produce, say, 160 units of nitrogen. It's a ballpark number that we can use then to plant corn into. At a minimum, that alfalfa field is going to produce 90 pounds of nitrogen. At a max, say, 190 pounds that we can use as a credit for the next crop. So once we terminate that alfalfa stand based on the height and the density of the alfalfa, if it's a very good stand, again, let's stick with our 160 pound number, we can use that nitrogen credit to grow our corn crop the next year. So we can no-till in our corn into that alfalfa and then not have to apply any additional nutrients to the crop. So we can use those nutrients that are already available. Of course, there might be some phosphorus or potassium needs based on soil tests, but nitrogen's already taken care of from that legume alfalfa crop. Manure provides the phosphorus and potassium credits too. So when we're applying, say, 20 tons of dairy manure to a farm, we may be getting a third to a half of the nutrients that we need for nitrogen from that manure. And then we may need to supplement some potassium. Typically, we don't have to supplement too much phosphorus because we've already built that up over time on those livestock operations. But if it's a rental piece farther away from the home farm, we may have to supplement those nutrients too. But those nutrient credits really add up in the long run, and there's additional values long term with those as well.
Once you determine you have a credit, Dan, how does it work? Do big companies buy these credits from farmers?
Really good question. That would be more of a carbon credit being purchased through these different conservation systems, but not a nutrient credit, unfortunately.
Okay.
Otherwise, Wisconsin dairy farms would be very wealthy.
So, Dan, what is the value then of having those credits?
Yeah, so it's similar to an accounting exercise where we're looking at balancing our checkbook. We have these credits that we have out on the landscape from our manure and our nitrogen from our legume crops. We subtract those off of a nutrient balance that the crop really needs. So we say our corn needs 160 pounds of nitrogen, 40 pounds of potassium, 40 pounds of phosphorus based on our soil test data. We can then subtract off those credits from our manure from that overall total that we need.
Now, you also mentioned a SNAP program. Is that a precision software program you use?
It could be classified as an early precision ag software program. So it's been around for quite some time, and it's essentially a program that allows farmers to combine their farm data with their nutrient data and then make a plan based on allocating that nutrient data across the landscape. A foundation of that is a soil test. So every acre is soil tested within that plan. That data is imported into SNAP Plus, and then SNAP Plus will calculate the nutrients we need to apply based on what the farmer inputs that they're going to grow. So we input a typical rotation, 4 to 8 years of data into the program, and then it calculates how many nutrients we need to apply each year. And then we can actually apply those within the software to say, hey, we're going to apply 20 tons of beef manure to our home field. And then that will calculate out if we need additional nutrients or not based on the soil test and the crops that we're growing using university recommendations.
Dan, just to be sure I'm understanding you and for clarity, a farmer will put information into the SNAP program. The SNAP program then generates data and numbers, and that information is then put into the nutrient pest management program that you run, correct?
Exactly. Yeah.
Okay. In addition to what you've already mentioned, Dan, what are other aspects of the nutrient pest management program?
Yeah, so we work a lot with soil health practices right now. So we have a statewide cover crop survey that we're doing in a collaboration with the Michael Fields Agricultural Institute, the Nature Conservancy, and USDA ARS, the Dairy Forage Research Center in Wisconsin. So this cover crop survey has been going on since 2020. We have about 250 participants so far, and our latest version of the survey asks farmers to fill out about a 35-question Google form to say everything about their agronomic management of cover cropping, but also why they cover crop and how long they've been cover cropping. So we collect some agronomic data via the survey. The agronomic data asks planting date, the species they're planting, what crops are in their crop rotation before and after the cover crop, if they've had any challenges with planting a cover crop, what are the benefits they see, where do they get their knowledge from their cover cropping. We also have an in-field component where we pay farmers to collect biomass from that cover crop. So we have that biomass analyzed for nutrient content. so we can begin to think about what kind of nutrients are being cycled by those cover crops and at what volume. We also have a forage component. Being in a very forage heavy state, forage brings a huge value to cover crops. And we're asking farmers to then send in a lab sample for forage analysis. Both those data sets have been very interesting to look at. We have very high quality forage being produced by our cover crops across the state. We also have some substantial amount of tonnage of cover crops being produced around the state. This is also helping improve grower perception and insights on where they can and can't plant cover crops and what crops in rotation work with cover crops. We're going to be publishing a 5-year report very shortly, kind of summarizing those 250 sites of data. It continues to grow. So we're starting our, 6th year already of the survey this summer. We'll be promoting that very shortly. So that's a pretty exciting component. And then we also do some regionally based soil health outreach activities. So these could include soil pit demonstrations, infiltration demonstrations, working on farmers one-on-one, implementing soil health practices like cover crops, reduced tillage, even thinking about if they're going to do some of the more advanced soil health tests and looking at that on an individual farm scale, and then helping advise some producer-led groups within the state of Wisconsin on overall soil health practices that those groups can then implement across a watershed.
Mother Nature never stops innovating, and farmers face constant pressure, weather, pests, disease. But BASF never stops innovating either. We innovate in our trusted technologies to develop breakthrough chemistry, seed technology, and digital tools that are more efficient, easier to use, and deliver real results. Why? Because we are dedicated to helping farmers do the biggest job on earth.
You talked about a soil health survey in there, Dan. So what exactly is in that survey and how do you utilize that information?
Yeah, so the early data set provided us really good insights into what cover crop species are working in northwest Wisconsin. And northwest Wisconsin would be defined as, say, north of Chippewa Falls, a very good crop growing region of the state and a region where we did not have much data on cover crops. So we have some outstanding farmers in that area of the state that have collaborated with us, provided us some really good benchmarking data on after wheat, we get some tremendous amount of biomass produced. After corn and soybeans, we're not surprised, but we really only have to plant winter cereal rye after corn and soybean grain crops because we just have limited growing season. So we're able to help producers make crop decisions to say, hey, if you really want to grow some diverse cover crops, bring in a small grain in that portion of the state. And then you have some really tremendous opportunities. We've also gained all the forage data from these cover crops. So Dan Marzu, one of my colleagues, has put together some information on using cover crops for forage value. Based on the survey, there's going to be a lot more to come from that. We have several seasons of forage data, and now we added a spring forage data component as well. So we have fall and spring forage data. One of the participant farms that I was on this last fall, he was able to graze his beef herd on cover crops for a substantial amount of time with a substantial amount of forage produced. And he attributed that to saving him quite a bit of money on feed, but also it allowed him to expand his acres that he was able to get his livestock on, because normally those acres would have been in a grain crop. Now he can have both the grain crop and the cover crop where he can graze.
I think that is a great example of how all the tools are put together to make the program work to the benefit of the producer. Now, you also mentioned that producers get paid for biomass. Tell me more about that part of it.
Yeah, so we pay farmers to collect a biomass sample as part of the cover crop survey, like a 2 square foot, well, actually, I think it's 4 square foot, 2 by 2 feet, so 4 square foot sample of cover crops. And then they send that in right from the farm into the lab. We pay for the lab analysis and the shipping fees. That then we get some data back. We share that data back with the farmer via several reports, and they can use that to make management decisions right away. But what we're doing is we're building a database then that is now searchable. And the Michael Fields Institute has led this portion of the project. They have a wonderful website set up where we can actually search by cover crop and location and attributes of the cover crop, such as weed suppression, nitrogen scavenging, forage quality. And that filters out those 250 results for farmers to use across the state.
About how many samples would you say that you get on average?
We have a really good response rate. So on average, we have 50 to 60 farms a year participate in the project, and we get about 95% of the samples back. So we're getting 50 to 60 samples back, which is wonderful. And we're very thankful of the collaborators.
Dan, going back to when you were talking about cover crops, let's focus on that here for just a little bit. What cover crops are you using in the program?
Yeah, so I'm working on now winter rye. We're really seeing that winter cereal rye is kind of the go-to cover crop across the Midwest for farmers to plant after any crop that they harvest. It's fairly easy to establish. There's a wide variety of ways that they can plant that cover crop. And then there's a lot of benefits the rye has, especially in early spring in the upper Midwest. The rye is going to grow at a much lower temperature than our grain crops would, and it's going to cover the landscape and hold the soil in place. What I'm very interested in is using rye for weed suppression. So actually allowing that rye to grow through early May, planting corn and soybeans into that rye residue, and then letting those crops somewhat grow together until we terminate the rye. But that rye residue then will smother the weeds out. It'll act like a straw mulch at that point, and that has tremendous value in helping us reduce our dependence on herbicides. As herbicides become a little bit more challenging to manage herbicide-resistant weeds, we're using that natural barrier of the rye to smother troublesome weeds like water hemp out. And it's highly effective, and we've had some really good success with that project. Other cover crops that I'm really interested in is interseeding red clover. And we've had tremendous success with planting red clover at, say, knee-high corn, and then allowing those two to grow together, and then either chopping the corn for silage or harvesting the corn for grain, and then allowing that red clover to grow the next spring. And in fact, there's a lot of interest in that in the forage systems too, because possibly we can incorporate diverse mixes in with that red clover for grazing and forage harvest to occur after those crops too.
How long does it take to establish good cover crops?
Yeah, planting date is very dependent on that, Lorrie. So if we plant cereal rye after our corn grain harvest, we may get the rye to just spike through the soil and just barely germinate before it goes dormant for the winter, and we get some snow cover even. If we plant the same crop after wheat, we may get a winter rye stand that's, say, maybe 6 to 8 inches tall. By the end of the growing season, and the field will be completely green and covered. At that point, we could even think about a forage or grazing operation going through that field. Typically, we don't because we want that biomass in the spring. So planting date is very important. We have farmers taking off wheat right now, thinking about planting cover crops. They'll have tremendous stands of cover crops. The fields will be green. They'll have anywhere from 8 inches to knee-high amounts of biomass produced out in the fields, and that will be great going into winter then. If we include a legume in that, we can consider having a nitrogen credit from that amount of biomass as well. Whereas when we plant anything after corn and soybeans, we're really just limited to that winter rye. After corn silage, we could consider oats. They're going to winter kill. We could consider barley or triticale as well, just depending on what our overall goal is, our seed availability, and the interest of the farmer and the experience that the farmer has planting those different crops and then managing the biomass in the spring.
Is there a lot of extra cost when utilizing cover crops in an operation, Dan?
There is cost to using cover crops, and we always want to start with our goal when we're thinking about the cost. So if I'm going to set out to suppress water hemp with, say, cereal rye, I'm going to plant anywhere from 20 pounds to a bushel of cereal rye in the fall after soybeans. My initial planting is going to have a cost to it. So my operation, whether it be applied with a drone, with a high clearance machine into, say, corn, with an airplane, I prefer to plant mine with a drill. So a drilled seeding is going to be about $15 acre cost. And that would be like a custom rate guide number. If we own the equipment, maybe it'd be a little bit lower, maybe it'd be a little bit higher if we had to actually hire someone and there wasn't anyone in our area. Aerial seeding is going to be a little bit more expensive than that, of course, too. And then we have the cost of the seed. And demand has risen quite a bit for especially early maturing varieties of cereal rye. So we're going to have the cost of seed on top of that as well, and that's going to add to that. So typically we see maybe anything from $26 to $30 an acre to establish our winter rye after our grain crops. And that's a very ballpark number because locally seed prices can be widely different, and we're seeing some more farmers grow their own cover crop seed, which I think is interesting. I think that should be explored more too. So we have that component. After wheat or after any crop that we may be able to plant a mix after, we're seeing farmers spend $50 to $70 an acre on those mixes. But there's more benefits to those. They may have a forage component. They may have a nitrogen credit component. But getting back to the rye, you say, well, we've got to pay for that $30 an acre cover crop. If we allow that to grow throughout the spring and then plant, say, soybeans into that rye residue, we may be able to reduce our herbicide costs by $30. Then we're also holding the soil in place, which if we start to pencil out a number on a ton of soil, we get to think about, well, what nutrients are in that soil? What's the organic matter potential of soil? And then the easiest thing to compare is if we lost a ton of soil, how much would we have to pay someone to come in and haul a ton back for us? And that could be, say, $70 a ton for the soil. Well, that's never going to replace the legacy factors of the soil. And it's not practical on a farm scape, of course, because 1 ton of soil is a very small amount of soil that we typically see lost in an average crop rotation. But soil loss can be 5, 6, 7 tons an acre and still not look like much across an entire farm as far as from the road, say. But it's a huge loss in potential nutrients, ability to hold water, ability to cycle water through it. So we really are emphasizing that soil health component of keeping the soil on the landscape with cover crop. And when you start to think about putting a number on that, it quickly pays back for that cover crop alone. We're also seeing increased water infiltration and water holding capacity with cover crops. And that's a huge thing for us in the upper Midwest. Up until this year, we had some dry springs, and we went from May 1st until July 9th without rain in 2022. And we saw the crops really struggle. And in fact, in some of these systems, they were really pushed to their limits of possibly needing to start over and reestablish a forage crop because there just had been a severe depletion of water in the soil. In our cover crop fields, the cover crops are shading the soil and helping the soil hold more water. We didn't see those issues. The crop was a little bit sluggish and was a little bit held back because it was that biomass competition component. But once those rains came, those crops really caught up quickly because they weren't stressed. They were in a nice, great environment of good soil moisture and a little bit lower temperature.
Dan, what are some other common questions you get from producers with regard to the program and your findings?
Yeah, we get a lot of common questions about when is the best time to plant a cover crop and when's the best crop rotation. But again, going back to that statement about the goal, the best time to plant a cover crop is when you can plant it, especially in the fall. If you can still go to the field in the fall, you can still plant cereal rye. It's maybe not going to come up until the following spring, but that's okay because typical Midwestern weather, we can get that rye to germinate in late March, early April, and it will grow for 5-6 weeks before we typically are in the field planting again. We're going to have a tremendous amount of biomass to plant soybeans in. Now, for folks south of us that really want to plant in late April, early May, that may change things a little bit, and we may not want to plant these ahead of corn because we really want to terminate our cereal rye before we plant corn. Otherwise, we've seen some yield drag. We're primarily focused on using rye after corn going into that soybean year for our corn and soybean producers.
I sure appreciate this in-depth and educational conversation we've had here today. Once again, Dan Smith, my guest, he is a program manager for the Nutrient Pest Management Program at the University of Wisconsin-Madison Division of Extension. For more information on anything we discussed here today, you can go to their website at cropsandsoils.extension.wisc.edu. I'm Lorrie Boyer for Successful Farming.
Thank you to our guest today, Dan Smith, for sharing your expertise on cover crops. Also, thank you to today's sponsor, BASF. For more information like this, visit agriculture.com. And don't forget to subscribe, rate, and leave us a review. You can also follow Successful Farming on Facebook, Instagram, and Threads. And be sure to check out our other podcasts, 15 Minutes with the Farmer and Successful Farming Daily, wherever you get your podcasts.